Hi, everybody. Hope y'all are doing well, as usual, I hope. Today is going to be a little bit of quicker recording, a shorter recording, because I'm just going to go over give an overview and explanation of what a couple more statistical analyses are and the purposes and those sorts of things. We're going to talk about ANOVAs and regressions. And then the reasons why it's shorter is there's some walkthrough and explainer videos that I've actually linked in the slides that you will view. So I found these videos and they do a really great job of explaining ANOVAs and regressions. So including them as part of the slides to go in and choose those links and watch them instead of me going over them as they do a very good job. So also want to just do another quick reminder, an assignment reminder of the quantitative research assignment. I want to point out something as well, that if you go to the Moodle page, let me pull that up. So pull up the Moodle page, sign in, obviously. So if you go down through the Moodle page to where it has our quantitative research assignment, you're going to see a walkthrough video. So that is available to help you. And even down at the bottom where we have our quantitative research assignment description at the bottom of the Moodle page, there's an actual walkthrough video of running these analyses. So utilize that as a resource, as that will be quite helpful for you. So just as a reminder that is due Friday the 28th. So that is coming up quite quickly. So please let me know of any questions, or we can meet one-on-one, or any support that you need for that assignment. Okay, so let's get into what are ANOVAs. Let's get into what are these different statistical procedures we're going to talk about today. So what is ANOVA? What does ANOVA do? So ANOVA is a statistical test that is used to compare the means of 3 or more groups to determine if there are significant differences among them. So ANOVAs evaluate whether the variance, remember we talked about variance, that's the spread of data, how spread out the data is within specific groups, is smaller than the variance between group means. So if we're looking at means, right? So the means of one variable versus another, or groups of variables, what variables are close, or the data points are more closely together? Which data have less variance compared to more variance? And so a couple of key concepts here are within group variance, between group variance, and interpreting results, the things that I want to talk about. So number one, starting with within group variance. So this through ANOVAs measures how much the values of the dependent variable differ within each group. So smaller within group variance suggests more consistency in the group. Now, between group variance measures how much the group means differ from the overall mean. So larger group mean variance, larger between group variance suggests greater differences between the groups. You can see the difference between those two. We're looking at, again, comparing of how spread out the data is. And so interpreting results, a couple hints here. So large differences in means, being the small within group variance, for instance, this indicates that the independent variable significantly influences the dependent variable. So the null hypothesis, that we call it a null hypothesis versus a test hypothesis. So a null hypothesis would be that there is no difference between these groups, would then be rejected, and we accept the test hypothesis that there is some sort of difference. Remember, we're testing your hypothesis in these sort of analyses. So now, on the other hand, small differences in means, this large within group variance, indicates a little evidence of differences between the groups. So then we would accept the null hypothesis. So let me go over that again, just so it's clear. So we have a null hypothesis going into this and a test hypothesis going into it. The null hypothesis is that there is no difference. There is nothing going on here. The test hypothesis is like, well, there is an impact here. There is some sort of difference. There is some sort of impact from the independent to dependent variable. And so large differences in means, that indicates that there is a difference. So we reject that null hypothesis and accept our test research hypothesis. On the other hand, small differences in means larger variance, which would then mean that there is not that statistical difference and that null hypothesis accepted, and we reject our research or test hypothesis. Maybe that's not super clear. It's okay. Review the notes. And again, those videos will explain that even further. And there's two different types of ANOVA I want to mention. So there's one-way ANOVA. This compares means across 3 or more groups for one single independent variable. Two-way ANOVAs ANOVA test compares means for two or more independent variable, potentially revealing interaction effects. So a practical example of this would be maybe you're studying the effect of study methods on test scores, and the independent variable is the study method. So whether it's a group study or individual study or not studying at all, and the dependent variable would be the test score. Here in this example, an ANOVA test would check if differences in test scores are statistically significant across these groups. So the group studies versus individual studies versus no study at all, are there specific group differences across those? So that's the purpose of an ANOVA. And so there are a couple of assumptions that we have with an ANOVA test, four to be exact. So one is that the dependent variable is continuous, things like test scores and income. Number two is that groups are independent with no overlap. Three is that data within each group follows a normal distribution, and that four variances across groups are approximately equal. So homogeneity of variance. Again, so think about how why you would choose to use an ANOVA as you're comparing means across different groups, right? Be thinking of examples, including those in your own field where ANOVAs might be useful. All right. So when to use ANOVA tests? ANOVA is primarily used when you want to determine whether there are statistically significant differences between group means. Again, it's especially useful when comparing three or more groups because for example, a t-test, which compares means, would require multiple different pairings and different comparisons, increasing the risk of errors. So we may have briefly mentioned t-tests, but ANOVA is the next step over t-tests. So a one-way ANOVA, when you would use a one-way ANOVA. So this is used when there is one independent variable and one quantitative dependent variable. So this test helps us to determine if the independent variable significantly impacts the dependent variable. For example, comparing the test scores, dependent variable, of students based on their study method, that like we just mentioned, right? Whether they're studying in groups or individuals or alone, or they're not studying at all. And then a two-way ANOVA would be used when there are two independent variables that might influence the dependent variable. So this allows the analysis of a main effect of each independent variable, so how each one independently affects the dependent variable, and then the interaction effect, which is whether the independent variables together have a combined effect. So we can compare, again, when you have multiple variables you think might be impacting one independent variable, we can use that to look at this. An example, again, would be comparing test scores based on both study method and study locations. So let's say you're looking at both whether they study in the library versus at home or in a dorm room, whatever that might be. In a two-way ANOVA, you could look at both of the impacts there collectively on the dependent variable as test scores. So when should you choose ANOVA? You should choose ANOVA when you have at least three groups to compare. So your dependent variable is also continuous, things like test scores and income. Your independent variables divide data into distinct categories, things like study methods or regions, et cetera, et cetera. And that for when you're looking to avoid the limitations of running multiple t-tests. And considerations before using ANOVA is that you want to ensure that your data meets the assumptions that we just talked about. And that ANOVA only tells you if there is a significant difference, not where the difference is. So to identify specific group differences, use different types of tests that we're not going to go into in this course. All right, so why is ANOVA useful? So ANOVA, by understanding these differences between group means, you can really pinpoint whether an independent variable, things like temperature, has a measurable effect or connection on a dependent variable like purchase rates or whatever it might be. Remember, study habits, group scores, whatever it might be. So that can be quite useful. And what this does is it allows researchers to test hypotheses and make better data-driven decisions based on group behavior. So it goes deeper than just the descriptives that we've been looking at in this course. So a couple practical applications of ANOVAs. Number one is understanding key drivers. So when group means differ significantly, it suggests to us that the independent variable may influence the dependent variable. So for example, examining how different landing page designs on a website, being the independent variable, affects things like click-through rates for the dependent variable. In a market, that can be very useful to know. A second practical application could be investigating multiple dependent variables. So ANOVA can also be used to analyze the effects of one independent variable on multiple dependent variables. And it can help you to see which ones are the most affected. So for example, studying whether temperature as the independent variable impacts multiple behaviors, things like purchase rates of sunscreen, attendance at outdoor events, likelihood to host a cookout. We can figure out how the effect of just one independent variable has on multiple dependent variables. That can be quite helpful. And then three, another practical application would be reducing decision-making guesswork. So what ANOVAs also can do, they provide a structured way to evaluate the significance of patterns and differences rather than relying on intuition and observation alone. So why are you going to use ANOVA instead of other tests, potentially? Again, ANOVA allows for the comparison of 3 or more groups simultaneously, which avoids the increased risk of error associated with running other things like t-tests. ANOVAs provide clear, reliable way to determine whether observed differences are statistically significant or due to random chance. Again, think of some more real world scenarios where maybe knowing these types of group differences are significant or would help and guide decision making. I mentioned there's some walkthrough videos. There's one here. I want to make sure. Yep. So it will play when you're in it. I'm going to pause it, but this is a SBS tutorial of one-way ANOVA tests. And then there is a two-way ANOVA test tutorial as well. So please go in and view each of those, but we will now get into regression as well. Just an overview of regression. So what are regression analyses? So regression is a statistical technique used to examine relationships between variables as well. It helps us to identify how changes in one or more independent variables influence a dependent variable, often to test hypotheses or model various social phenomena. So again, regression is a fundamental tool in sociological research. And as you take more advanced statistical classes in sociology, you will absolutely use regression analyses. And regression, it quantifies relationships between variables and determines whether those observed correlations are statistically significant. So for example, regression can help us understand how education level, income, and family structure all influence voting behavior. We can look at those things from multiple angles. Some key concepts that we need to understand, though, about regressions, there's some key components like a dependent variable, right? So that's the outcome of being studied. So things like voting behavior or whatever it might be, or test scores. Independent variables as well. So factors believed to influence that dependent variable, whether it's education, income, study habit, all those sorts of things, right? What's influencing the outcome or the phenomena being studied. And then the concept of statistical significance, which we already have talked about. This indicates whether the relationships that we're observing in these tests are likely due to chance or represent an actual meaningful pattern. So when there is statistical significance, that means there is a meaningful pattern going on here. And so there's a couple different types of regression. There's linear and logistic regression. So linear regression is used when the dependent variable is continuous. So things like annual income levels. Logistic regression is used when the dependent variable is binary. So like, did you vote or did you not vote? Yes, no, binary choices there. Some examples, an example in sociology would be, like a study on healthcare access. So regression analysis can help identify how variables like socioeconomic status, age, and race, these things predict the likelihood of visiting a doctor, for example. And this provides more actionable insights into health disparities and whatnot. Causation versus correlation here as well. So regression shows correlations, but does not inherently prove causation. Remember, we talked about correlation does not equate to causation. So researchers have to just carefully interpret the results and consider additional factors such as omitted variables or confounding effects, which we talked about on the correlation side of things. There are some limitations I've noted as well in the notes, so feel free to go look at those. Those include multicollinearity. That's like when independent variables are highly correlated to the independent, not just the dependent. As well as omitted variable bias. So we're excluding important data that can lead to misleading conclusions. And then overfitting is another. So where we're using too many variables in the model to make predictions unreliable for new data. Some other practical applications of regression. So we as sociologists use regression to analyze a variety of social issues, such as For example, predicting educational attainment based on family background and school quality, or modeling the impact of urban development policies on housing affordability, or examining the relationship between media consumption and political attitudes, for example. So all these are different types of applications of regression. Now, these different types of regression that I mentioned, right? So let's dive into these three. So simple linear regression. So you have simple linear regression, you have multiple linear regression, you have logistic regression. So let's start with simple linear regression. This is where we're examining the relationship between one independent variable and one dependent variable by fitting a straight line through the data, essentially. So the purpose here is to determine whether changes in that independent variable predict changes in the dependent variable. A couple assumptions with this is that the data is collected using a representative and valid sampling method. Number two, that no unobserved confounding variable explains the relationship, and that the relationship between the variables is linear, meaning that the best fit is a straight line, not a curve. Remember, we talked about what's linear correlations versus a curvilinear correlation. Multiple linear regression, on the other hand, extends this idea of simple linear regression by analyzing how several independent variables influence a single dependent variable. So an example in sociology could be examining how income and education and social capital, how these things can predict health outcomes. So some key assumptions of multiple linear regression is that a linear relationship exists between the independent variables and the dependent variable, as well as that the independent variables are not highly correlated with each other, and then that the residuals, so those errors, are normally distributed and of equal variance. So those are some basic, that's kind of the difference between linear, simple linear and multiple linear regression. And why is this useful? So sociologists often deal with complex phenomena, right? It's society. So where multiple factors, things like race and class and neighborhood, socioeconomic status, all these things interact to shape our outcomes, like academic achievement or health related outcomes, or achievement or crime rates, those sorts of things. Finally, logistic regression is used to model the probability of a binary outcome, such as yes, no, or success, failure, or unemployed versus employed. And so examples in sociology where we might use this, examining whether gender, education, or marital status predict the likelihood of voting in election. Did you vote or did you not? Again, it's that binary choice, not a continuous choice. And how this works, so instead of predicting a continuous value, logistic regression predicts the likelihood of an event occurring. So values between 0 and 1. So 0 didn't occur, 1 did occur. Applications in sociology. So logistic regression is especially useful for sociological studies involving categorical outcomes. So such as whether a policy reduces poverty or whether a program increases graduation rates. So we're just looking at the efficacy of something, whether yes or no. Does it increase or does it not? So more simple, looking at things in a binary way. Again, I mentioned videos. So there are a couple of regression walkthrough videos that I want you to watch. They are on, again, linked in the slides. We're not going to watch them here right now, but there are a few different ones that can be helpful for you. So I also wanted, the last thing I wanted to talk about, so that's ANOVA, and I know I went through them fairly quickly because these are not things we're being tested on in this course, but I want you to be aware of them, especially if you move forward and whatnot. But dataset codebook. So a codebook is I'm thinking about when you've collected your data, right? You have your data set. How do you code and sort your data set? We talked a little bit about what coding looks like, but a code book is a critical document or a tool used in the context of data analysis and research to provide more detailed information in describing a data set. So a codebook serves as a guide that explains the structure and the content and actual meaning of the data. So it makes it easier for us as researchers or us as analysts to interpret and use the data set accurately. So a typical codebook can include various things, various components like variable names and descriptions, variable types, variable labels, the units of measurements. What are we actually measuring in it? Coding information. So how did we code this, say, for example, survey data? The data source, the survey questions, the variables, the variable labels. Again, data set structure itself. So all these sorts of things, what might be in a code book, and why is this important, and why might you construct a code book someday? So it helps in 4 key ways. Number 1 is interpretation. So a code book helps users understand what each variable represents and how to analyze it correctly. Number 2 would be transparency. So a code book provides documentation for others who may want to use that data set. an error reduction. So this we're preventing misinterpretation or misuse of variables and values. And then finally, we're able we can by having a codebook, we can better reproduce or replicate our studies and analyses. Now, you can see an example of a codebook. So I'm going to open it up there. And this is actually a study that I was a part of. I was just an associate researcher at the time. But you can see the different tabs for the different study areas. And really, this is a very simplified code book because you don't have as much of the descriptions of, okay, what does each variable mean? But the purpose of this code book was simply to look at all of our data more succinctly in better tables, sorted by concept, so we could understand, okay, what actually is this data set showing us? So it's not just, say, your basic frequency tables. There's more description here. And you can see you have your frequency, your valid percent of thousands and thousands of respondents here. And response, this is a better way to sort it. So that's one example of a codebook that you can take a look at through this class here. So please let me know of any questions you have around the code book. But the idea, again, is better sorting explanation. So someone who's not familiar with, say, the study that you conducted or the survey that you conducted, whatever it might be, that person can walk in and understand the data by reviewing the code book. You have all the explanations you need. Finally, again, just an assignment reminder, again, that we have our quantitative research assignment due. So as always, please let me know of any questions that you do have about this session, any of the videos within these slides, or about your assignments, anything at all. Coming up, we will start our third unit of qualitative research. That'll be fun to do. Again, please, thank you for tuning in, and please let me know of any questions that y'all have, and we can connect one-on-one as we've continued to do. Thanks, everybody.